I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
Well, here it is complete, except for 3 large holes, which you may notice here, here, and here. But otherwise, it's all wired up. A couple of test leads have been made. And power is coming in right here from the 9-volt DC wall wart. Let's talk about these 3 missing pieces here. The first and most critical is this guy. And this is a Arduino Pro Mini computer, if you will. It's not blazingly fast, and it has very limited memory, but it's very small and very cheap, and it's designed to do one thing and about one thing only. So you can load software onto this. It will repeatedly run that software once it's loaded until this wears out, I suppose, or until you turn power off, of course. But it's an Arduino card. It's designed as an Arduino card. It's actually made by somebody else. Who knows who? Widely available. Arduino, by the way, is an Italian company, or started as an Italian organization. A bunch of folks were believers in open source hardware and software, so they created Arduino, and they're a thriving organization right now. Lots of companies make Arduino compatible hardware, and a lot of it comes from China, and it's really super inexpensive. So this is the processor. This is the heart of this the sweep generator. I shouldn't call it a sweep generator. It's more than that. It's a sweep analyzer. And it goes right here in this socket. But I won't plug it in there right now. The second thing is this module right here, which is also an Arduino compatible module. And this guy is the signal generator. This is what, you can see a crystal right there under my thumb. This is what generates the all the signals for the sweep analyzer signal generator portion. And finally, the display. This is a TFT display. The first version of this board, this is version 4.1, the first version, version 1, and there's no 2 or 3 as I read it, but version 1 had a different display module that was discontinued. Nobody made it anymore. So Mr. Whipple had to update the circuit board to use another TFT display. But that's here, and we'll hopefully see this in action later. So this is a computer. It's an Arduino computer, and what you need to do is be able to load software onto this card. And the software in Arduino world, instead of programs, they're called sketches for reasons that I don't know, probably lost in some historical, well, there's some good reason, I'm sure. The Arduino card, like all Arduino card, well, not all, but is a serial data machine. I don't know if I can get this close enough to show you here. There's a RD pin right here, receive data, and a TD pin right here, transmit data, then VCC and ground, and one other signal pin, I think, over here, yeah, DTR. These are the pins you use to program this card. But how do you do that? Well, this doesn't have a USB connector on it, so you can't connect it directly to your computer. However, you can buy, for very little money, a thing called an FTDI interconnect board. And FTDI is a Scottish company that makes this chip right here. And what they do is they interface USB data with serial data on this card. So this thing is what allows you to connect your Arduino Pro Mini CPU into your computer using a standard USB, I don't know which one is this, B connector. So the transmit pin, which is the second one in, transmit pin on here goes to the receive pin on here, and that's marked right here. And what you find out, you have to pay attention to this when you do this. You find out that in this particular case, this one goes upside down, so that the transmit pin, that one, the second pin, can go to the receive pin over here. So that goes in there upside down. And now you can connect your computer to this FTDI card and download a sketch into this, which will then operate all of this. So the first thing we're going to talk about is the process of getting the sketch and the software necessary to download the sketch into this Pro Mini. So that's next. The place to start with the software portion of this project is right here. This is a website, GitHub, GITHUB.com, and GitHub is GitHub is a repository for a lot of open source software, tons of it, and Richard Whipple chose to use GitHub to store and make available the software he's created for this WSAB project. So this is the URL. I'll put a copy of it in the comments below. This is the page you'll see, and right here is a little comment that's important when it comes to putting the WSAB together, the version 4.1, and that is that the original 10-pin display is no longer available. He's updated the schematic in PCB with a new 11-pin display. There's a 12 holes in the circuit board for the socket for the display. Only the leftmost 11 pins are used. So what Mr. Whipple has provided here is a whole bunch of files. The ones you're probably must pay most attention to is this one right here for one. This is the parts list. Let's see if I can get that open. Yeah, here's the parts list. Includes all the parts that you'll need to put this together. There's one flaw. I think it says 20-pin socket right here. This one right here, this Jamico 112248, is incorrect. That's the wrong socket for the signal generator. But otherwise, all the rest of them are correct. If you get all these parts, and you needn't buy them all from Jamico, like he has listed here. You can buy them from your favorite parts vendor, but Jamico has most of them, and he's kindly put all the Jamico parts so they're really part numbers, so they're really easy to find. So that's the first thing you'll want to pay attention to. The second is down here. Oh, if you want to see how the circuit board is laid out, and even if you want to have your own made, these are the files you'll be interested in, particularly this .pcb. This is the circuit board design right here. You could send this file off to I can't remember the name of the company, but one of the circuit board manufacturers, and they can make one. It can't go to any circuit board manufacturer. Only one uses this particular file type right here. But what we're interested in right now are these two directories here. One is called source code with zip in parentheses. The other is called source code with tar.gz in parentheses. The zip file is the one we'll use to download the software onto this computer that you're looking at right now. The tar, which is an iMac, by the way. The tar file is typically used for by Unix or Linux computers. Although an iMac or a Windows machine can certainly unzip a tar file as well. So this is where the code lives. This is where the software lives. And you'll have to download this software. You can do it by clicking on it, as I recall. Yes, it goes up in here to my download bin. And then once it's in your download area, your download folder, you need to copy it over to the folder of your choice, or you can run it from there. But that will get you the sketch that you need to download into the Pro Mini. The next thing we'll talk about is where to get the software that you need to run the sketch, to load the sketch onto the Pro Mini. And that's called the Arduino IDE. The Arduino IDE is located on this website, www.arduino.cc/en/software. The Arduino IDE is free software. There's a page coming up that you'll see here in a second that will nudge you to donate to them. But it's an open source site, and they can use the money, but if you don't have the money to pay them, you can still download the software. Download options are for Windows, right here, for Linux applications or Linux computers right here, and for Mac OS, which is what I have. I have an older iMac running Intel hardware Catalina version. So this is the one I would want to download, and again, it's the same thing. Click it. They ask you if you want to support them or just download it. Throw them a few bucks or just download, your choice, and it downloads it into your download folder. Once you have it into your download folder, you can install it and run it for the first time, and I'll show you what that looks like. When you run the Arduino IDE software for the first time on your computer, what you'll get is it'll look something like this. You'll see a couple of things here. One is that it loads a sketch template for you. This is what a sketch looks like in its most basic form. There are two parts. There's a setup section, and this is where your setup code goes, as it says here. And then there's the loop. So what happens is when a sketch is written, all your variables and so on are declared in your setup, and all the main software that does the work is located here. You'll notice right here it says Arduino Pro or Pro Mini. That's because I've already run this software and I know that's what I'm running. That's what you have to select it. But you can select any number of boards. There are so many Arduino circuit boards that this IDE will play with. All of those in dark print that you see scrolling by, including the Pro and Pro Mini, which I have checked right here. The other thing you'll notice is there's an entry for ports. I don't have the FTDI card plugged into my computer at this second, so it's only showing my Bluetooth port as an open port right now. So I'll plug the FTDI card into the Pro Mini, and then plug the USB cable into my computer, and we'll take a look and see what that looks like. And another port popped up. In my case, it's dev-/cu.USB serial. So that's the USB serial connection to the FTDI card, which is in turn connected to the Arduino Pro Mini card. The card is ready to accept a sketch to be downloaded. So that's the next thing. We'll click OK here. Now we're ready to download the sketch. Here's a look at my directory, my Whippleway. I created a directory, a folder, if you will, called Whippleway VRA-FS. And in this folder is where I keep all the WSAB folders and files, things that I need. And the one that we're interested in right now is right here. It's this file called WSAB_code_version_1.ino. That's the INO is the extension for the Arduino IDE, and that's the file that will load into the Arduino IDE in just a second. But in here I keep all the stuff. There are files that are only interesting if you've got the book, because he talks about the ICO HFT90 in a couple of instances in the book. Some other things, the schematic for the WSAB is in here, and so on. But the code is right here in this one file called WSAB_code, and this is what you get when you unzip that zip file that we were looking at a moment ago. So let's go back to the Arduino IDE and download this INO file, or load it, I should say. Okay, I've drug the directory containing the INO file over the top of the Arduino IDE, as you can see here. And all I'm going to do is, since this code is what I want over here, I'm just going to drag it and drop it. That's the easiest way for me to do it. So I'll drag this over here, I'll drop it, and there it is. It's all of the software, almost all of the software necessary to run the WSAB card is now loaded into the Arduino IDE. So let's take a real quick look at this. This is a lot of software. You don't have to understand how any of this works if you're not a programmer. If you're a C++ programmer, this should be obvious to you. Fundamentally, all we're concerned with right now are these two lines right here. This one that says #include, then left arrow tft.h and right arrow, and the second one that says #include, left arrow rotary.h, right arrow. These are two libraries. Libraries are supplemental software packages. In this case, this tft.h package right here, a library, makes it easier to display data on the TFT display. The rotary, because the WSAB uses rotary switches in 2 instances, this library right here makes it easier to program to make the rotary switches behave in the way you want them to behave. So there are 2 libraries, TFT display library and the rotary encoder library, and they are both located on that github.com site in these directories right here. And you can copy this HTTPS link and open in your browser, and I'll show you what that looks like for the TFT and the rotary encoder library. This is the link. This is the web page to download the TFT library. It's Arduino-library/TFT on the GitHub site. You can see the URL right there. You can go to github.com and search for TFT. You'll probably have better luck just entering the URL directly into your browser, however. Here's all the information about this library. You don't need to do anything with any of this. You don't need it. But what you do need is the code for the library, which is over here in this green box. And I'll click on that. I'll click on that again. And right here is what you're interested in, and that is download zip. Now, you can't just download this library to anywhere. It has to be, in the case of my Macintosh, my iMac, it has to be in a folder at the top level of my Documents directory. And under Documents, there's a folder called Arduino. And in the Arduino folder is another folder called Libraries. And that's where this zip file goes. So you download this zip file, and wherever your download directory is, I just downloaded it here. You copy this tft-master.zip over into that directory that I talked about, and I'll show you that to you. In my documents, my top-level documents folder, there is a folder called Arduino, and then there's a folder within that called Libraries, and if we look in here, there's nothing there. This is where we download or drag and drop, however your favorite way of moving it, but I'll move this TFT master folder or file over to my libraries file and let it go. And that's the first library we have to have. Now let's look at the next library we have to have. The next library we need, looking quickly back at the sketch, is this rotary.h library. It's also on GitHub, and there's the URL. And we'll take a look at that. And here it is here. This one, this library was developed by a guy named Brian Lowe. As you can see his name right there. It's under github.com/brianlowe/rotary. There are other rotary libraries in the GitHub collection, but this is the one that the author of the sketch chose. Mr. Whipple chose this one, and so you need to use this one. Don't go astray and use another one. Same process. We go to Code, and then download the zip folder under Documents, Arduino, Documents/Arduino/Libraries, if you think about it that way. And then I'll just go over here and grab the download of the rotary and pull it onto our libraries window, and there it is. It's downloaded 2 zip files. And that's all you need to do to get the libraries in place. So now let's go back to the Arduino IDE and see how we load these libraries into that piece of software. Okay, I've expanded what you can see here a bit so you can see what I'm doing up here in the menu bar. So we've downloaded the 2 libraries that we need, and now we need to get them into the Arduino IDE and this sketch. So how do we do that? We go to Sketch, and right here you'll see Include Library, and over here is Add a Zip Library. So that's what we've downloaded. We've downloaded 2 libraries that are in zip format. We don't need to unzip them. The IDE will take care of that for us. So you just click on that, and then it will ask us where the libraries are. They're in Documents. Oop. The Arduino file, Libraries, and here they are. Rotary Master Zip and TFT Zip, and I think you have to do them, yeah, you have to do them one at a time. You can't select them both. You're either going to open one. So we're going to open rotarymaster.zip first, and it says library installed right there, and then we'll go do the other one, Sketch, Include Library, Add Zip Library, and we're back to where we were. And now we want the TFT master zip, and we'll open that one, and it's library is installed, successfully installed library. So at this point we have both the libraries that Richard Whipple is called out here in this sketch, and we have the body of the software itself that he's written to run the WSAB. Okay, we've got our sketch and our libraries, our 2 libraries in place in the Arduino IDE. So now we have to, only 2 steps left. Trust me, it's easy. The first one is to click on this checkbox right here to make sure that this code is clean, is installed or loaded on the IDE correctly. So we'll just click on that. It's compiling the sketch. It says it's done compiling, and everything looks good here. Very small, it's using, that's interesting. The sketch uses 24,298 bytes, or 79% of the total storage space available on the Pro Mini. So the Pro Mini doesn't have a lot of storage space. Oh, there's the maximum right there, 30,720 bytes. So you can't load a huge program on these things. So that's the verification stage done. All that's left to do is to download this into the Pro Mini, and pardon me. And all you have to do at this point is make sure that your Pro Mini is connected to the FTDI card, and it's plugged into your computer, and the red light is blinking on the Pro Mini card, and you click this button right here, and it will upload it. I keep calling it downloading because that's what it feels like to me, but it's uploading it to the Pro Mini when you push this button right here, which I will do. And I'll show you the picture-in-picture what it looks like when it's loading. And it's done uploading. All right, so that's all we have to do with the software. We've got the program, we've got the sketch downloaded into the Pro Mini. I can unplug the USB cable from my computer, I can separate the FTDI card from the Pro Mini, and the Pro Mini is ready to go. At this point, we have the sketch loaded into the Pro Mini. We can unplug the RTFD or FTDI. Geez, I can't remember that. FTDI card. Don't need that now unless we need to reprogram this. You'll save it for your next Arduino adventure. Now we can start populating the circuit board. I'll unplug the voltage here. This Arduino card is, I guess it fits. It goes in there okay. Here's the signal generator card, the AD9850 module, and it goes with the crystal facing toward the front of the sweep generator, and then goes into its own socket. Thusly. And finally the TFT display. The TFT display, this circuit board has a couple of holes for offsets or standoffs to hold the upper end of the TFT display in place. Those holes aren't quite in the right place on this card. So I have to fudge that a bit. And remember that when we looked at the software, it said make sure that when we looked at GitHub, before we downloaded the sketch, it said that there will be a spare hole on the right on the TFT connector. So we'll leave a spare hole on the right, and we'll plug the rest of these in. And now you can see my problem with the offsets. This card is slightly larger than the footprint left on the circuit board. So I'll have to fudge that a bit, but I'm not going to do it right now. Now at this point we've got our smart cards in. We have power right here. And here's the on-off switch. And we should see something come up on the screen that makes some sense. So let's see. Oh, power to the wall wart. WSAB version N-V-1, and there's the display. You can notice it's a refresh rate is very slow. I don't know whether they're all this way or it's the nature of the not very fast processor, but it's refreshing this screen at a very slow rate. We can see right here though that it's apparently working. It says sweep mode is AM, the IF is in kilohertz, and right there is our friend 455. This is the bandwidth of AM right here, or within these two bars, I should say. Down here we've got some other numbers that don't make any sense to me yet. And I'll have to read the manual. But as far as I can tell, it's working. It's running the sketch, it's running the software. The display is functioning, even though the refresh rate is very slow. I presume the signal generator is generating a signal that would come out of here, and go back in here. Next step, we'll have to explore what all these controls mean. By the way, these are the two rotary switches I was talking about right here. I was looking at the screen to see if I could see any difference, but I don't even know what they are yet. It's all right. Oh, I can see that one. If I turn this rotary switch, there's a little green, I don't know if you can see it, there's a little green bar right there. I turn this rotary switch, that green bar moves left and right. Cool. Okay, I'll turn this off for now, and we'll figure out how to use it in the next video.